Welcome to the era of smart buildings, where technology is transforming the way we interact with our environments. Today, we're exploring how artificial intelligence and the Internet of Things are revolutionizing building management systems. Imagine a building that not only responds to your needs but anticipates them, optimizing comfort, efficiency, and sustainability. This isn't science fiction, it's happening now. In this video, we'll break down the key trends, real-world examples, and future possibilities that AI and IoT bring to modern buildings. Let's dive into the future of intelligent automation and interconnected spaces. Internet of Things, or IoT, is at the heart of smart building evolution. In simple terms, IoT refers to a network of connected devices that gather, share, and act on data. Within buildings, these devices range from wireless sensors to smart meters, all working together to create a seamless, responsive environment. By enabling real-time data exchange, IoT devices make it possible for building systems to communicate and adapt instantly. This interconnectedness is what sets smart buildings apart from traditional ones, paving the way for advanced automation and efficiency. Let's look at some common IoT devices found in smart buildings. Wireless temperature and humidity sensors monitor indoor climates, while smart meters track energy, water, and gas usage. Occupancy and motion detectors help manage lighting and HVAC systems, and environmental sensors keep tabs on air quality. Even smart plugs and relays play a role, allowing remote control of various devices. Together, these tools form the backbone of a responsive, data-driven building ecosystem, making operations more efficient and adaptable. Benefits of integrating IoT into building management systems are significant. First, IoT devices reduce wiring and installation costs, making it easier to upgrade or expand existing systems. Scalability is another major advantage. Buildings can add new devices as needed without major overhauls. Most importantly, real-time data streaming enables deeper analytics, allowing facility managers to make informed decisions quickly. These benefits collectively lead to smarter, more cost-effective building operations. Artificial intelligence takes smart building management to the next level. AI systems can learn from data, detect unusual patterns, and even make decisions without human intervention. This means buildings can automatically adjust settings for comfort, predict when maintenance is needed, and optimize energy use. By leveraging AI, building management becomes proactive rather than reactive, leading to better performance and occupant satisfaction. AI's capabilities in building management systems are vast. For example, predictive maintenance uses AI to analyze trends and forecast equipment failures before they happen, reducing downtime. Automated set-point optimization adjusts temperature and lighting based on occupancy and weather, ensuring comfort and efficiency. AI also models energy consumption, detects anomalies in system behavior, and learns occupant preferences for personalized comfort. These use cases highlight how AI transforms building operations from routine to intelligent. Synergy between AI and IoT is what truly powers smart buildings. Here, how it works. IoT devices collect data at the edge such as temperature or occupancy. This data is sent to the cloud where AI engines analyze patterns and make recommendations or automate actions. The results are then visualized on user-friendly dashboards, giving facility managers real-time insights and control. This architecture ensures that buildings are not just automated, but intelligent and adaptive. Let's break down the data flow in a smart building. First, IoT sensors gather information from various points, think temperature, occupancy, or air quality. This data travels through gateways to cloud platforms, where AI engines process and analyze it. The insights generated are then displayed on building management system dashboards, allowing for quick decision-making and automated responses. This seamless flow of information is what enables real-time optimization and adaptability. See these technologies in action. Let's look at a smart office building. Here, IoT sensors detect when rooms are empty, automatically turning off lights and HVAC systems to save energy. AI predicts occupancy patterns based on historical data, preconditioning spaces before people arrive. Air quality sensors trigger increased ventilation, ensuring a healthy environment. These combined efforts result in significant energy savings and improved occupant satisfaction. Results of integrating AI and IoT in smart buildings are impressive. In our office example, energy usage dropped by 35% thanks to automated controls and predictive analytics. Indoor air quality improved, leading to healthier and more comfortable spaces for occupants. These outcomes demonstrate the tangible benefits of smart building technology, not just in cost savings, but in creating better environments for everyone. With all this data flowing through smart buildings, security is a top concern. Ensuring encrypted transmission and strict access control is essential to protect sensitive information. Building owners and managers must prioritize cybersecurity, implementing robust protocols to safeguard data from unauthorized access or breaches. As smart buildings become more connected, maintaining data privacy and security will remain a critical focus. Another challenge in smart building technology is interoperability. With devices from different vendors and varying communication protocols, ensuring seamless integration can be complex. Facility managers must carefully select systems that support open standards and can easily communicate with one another. Overcoming these challenges is key to unlocking the full potential of smart building ecosystem. Implementing AI and IoT in buildings often comes with higher upfront costs. However, these investments are typically offset by long-term savings in energy maintenance and operational efficiency. It's important for stakeholders to consider the total cost of ownership, factoring in both the initial setup and the ongoing benefits. Over time, the return on investment for smart building technology can be substantial. As the number of connected devices grows, so does the demand for bandwidth. Managing large streams of data from countless sensors requires robust network infrastructure. Building managers must ensure their systems can handle the increased load without delays or interruptions. Planning for scalable bandwidth is essential to support the expanding ecosystem of smart building devices. One of the most exciting trends in smart buildings is the use of digital twins. These are virtual replicas of physical spaces, allowing real-time simulation and monitoring. With digital twins, facility managers can visualize building performance, test scenarios, and optimize operations without disrupting the actual environment. This technology is paving the way for smarter, more responsive building management. Self-learning algorithms are transforming comfort control in buildings. These AI-driven systems continuously analyze occupant behavior and environmental data, automatically adjusting settings for optimal comfort and efficiency. Over time, the algorithms become more accurate, learning preferences and predicting needs before they arise. This level of personalization is setting new standards for smart building experiences. Voice-activated interfaces are making building management systems more accessible and user-friendly. Imagine controlling lighting, temperature, or security simply by speaking a command. Integrations with popular voice assistants like Alexa are becoming more common, streamlining building operations and enhancing user convenience. This trend is making smart buildings even smarter and easier to interact with. Edge AI is a game-changer for smart buildings. Instead of sending all data to the cloud, Edge AI processes information locally on gateways or devices. This reduces latency, enhances privacy, and ensures faster responses to real-time events. By distributing intelligence closer to where data is generated, buildings become more resilient and efficient, even when connectivity is limited. Smart buildings are increasingly integrating with ESG, environmental, social, and governance reporting and carbon tracking tools. These integrations help organizations monitor their environmental impact, comply with regulations, and achieve sustainability goals. By leveraging AI and IoT, buildings can automatically collect and report data on energy use, emissions, and other key metrics, supporting greener operation. AI and IoT are not just futuristic concepts, they are powering today's most advanced buildings. By merging real-time connectivity with data-driven intelligence, smart buildings are becoming more adaptive, efficient, and sustainable. The technologies we've discussed are already making a difference in offices, homes, and public spaces around the world, setting new benchmarks for what buildings can achieve. Summary: smart buildings are evolving from automated systems to truly learning environments. With AI and IoT working together, buildings can sense, analyze, and respond to changing conditions in real time. This shift is making our spaces not only more comfortable and efficient but also more sustainable and future-ready. As technology continues to advance, the possibilities for smart buildings are virtually limitless.